Okay, I really like that song. But we should get started, I guess, right? So, good evening, everyone, and welcome to my 109th live stream. I'm Genway Coldwind, and we are going to chat today about GW Basic, or rather, this is the third live stream about it, and we will be continuing coding and I don't know what, basically a tokenizer for the source code of GW Basic, which was written in an ancient variant of x86 assembly, basically. So I have no idea how to compile it, and for the last couple of streams, we were basically working to compile it some way. Today's moderator is Foxtrot Charlie. You can see his nickname right here. So if you have any questions or anything during the chat, you can reach out to Foxtrot Charlie. And then he will put the question in my question panel, so I will be able to answer it later, or at the beginning actually, because I usually do 10 minutes of questions at the beginning. So yeah, if you have any questions, write to Foxtrot Charlie. On the other hand, there's also a bot. If you write !Q, then you can just write the question after that, !Q question, and that will also get to my panel. I know there are a couple of more moderators today. I think KrzaQ mentioned that he'll be here, and I think disconnected as well. So hello everyone. And yes, let's I guess do some standard stuff at the beginning. Let's see if this works. It works. Which standard stuff meaning, well, some announcements or something, whatever you want to call it. So this is the website of my main moderator, Foxtrot. That's foxtrotlabs.cc. Take a look, maybe there are some new posts. Are there any new posts? Yeah, there are, well, from May. That's something, that counts. Perfect. And it's actually a solution to my challenges, which if you didn't know about my challenges, if you go to challenges, that's fine. Yeah, like challenges.ginveil.stream, and the ports are from 5000 to 5006, and these are like web challenges. The first one is using Flask, these are using Node.js, like from 5001 on to 5006, and just like change the port number and try to get the flag. Basically, at the end of the day, you need to get the flag. They're quite fun. You can find write-ups about them on blogs, so if you get stuck, you can just read about it. Cool, then, oh yeah, there will be a web conference, or webference. It seems to be every conference, every virtual conference has a new word for it, like a virtual conference, webference, whatever. Virtual Rust Day. So if you're into Rust language, you might want to tune in. There will be also a hackathon, I believe, and yeah, I'll give you a link. Then, do I have anything else? I don't think I have too much else. Actually, I do. Let's go here. So there's a conference which I organize. This is the 5th year, and the conference is in Polish, and it will be also a virtual conference. But the call for papers is like accepts and welcomes talks in English. So if you have a good topic security-wise or programming-wise, then I'll leave you links on the chat to both call for papers. Okay, so this is one link, and this is the other. One link is for the security track, the other link is for the code track, and there's like a different form for each of these. So yeah, take a look. The conference is actually, it has been going for 4 years now. This will be the 5th year. And it's like super technical, basically, at the end of the day. So yeah, really technical talks are really welcome. Okay. So I think that's it. Now, if you do not have the link to the GW Basic repository, which we will be working on, I also gave you it on the chat. And yeah, this is basically like the stuff we are trying to parse. So currently the idea is to write a parser for this, to tokenize it, write a parser, and then when we have the parser and have it in a form which can be easily processed to go either way, we can, I will decide, I guess, in the end, if we will go the way of an emulator or like interpreter, I guess it might be the way of the interpreter rather than emulator, or the way of actually assembling it into binary code and linking. Both options have pros and cons, so yeah. But today it's still like the second episode basically of writing the tokenizer, so don't expect anything too, I guess, flashy, too magical. Yeah, we have already some. We on the last time we basically did what we got last time is basically proper splitting into simple tokens of every line. And now what we need to do is we need to determine the purpose of each line and get... I'm not going to go with a full abstract syntax tree, AST tree, how you would normally go. I'm going to go to a list of high-level tokens, basically. So the final goal is basically if I have like this is, I guess, like a macro assignment, or like this is a more complicated one, then what I want to get is I want to get a line which says, hey, I'm like a macro or a constant assignment, and this is the value. And this is like will be a set of simple tokens, I guess. So yeah, that's basically the idea here. I guess like these constants I should be able to determine each and every value of it, because it's just like, yeah, just bitwise stuff. Yeah, and that's one thing. The other thing will be like, I wonder what's the difference between like dB offset C and this. Oh, because this is actually, no, oh, we already established this is octal, by the way, yeah. So I have no idea what's the difference, offset C, between dB and nx. We'll have to figure it out later. And then there will be assembly instructions and stuff like that. Yeah, we'll have to also deal with that, but that's fine. Cool. So, okay, are there any questions? If there are any questions now, I don't think there are any questions. Yeah, no questions. So we can jump straight into coding. Okay. Oh, I forgot to mention, today's live stream might be a little bit shorter than usual. So I apologize for that, but here we go. This is the code which we have. Let me run a Linux console, and let's run Python 3 parse on it. Yeah, and this is basically what we did last time. So we are getting a line, like for example this one, and we are getting a list of, this is the list of tokens here, like token identifier, something, then token assignment operator, and a token, a literal 0. So yeah, this is what we get and what we now will be working on. We are no longer working on this text form. We are now going to work on these simple tokens. That's why it's S token, because it's a simple token. Yeah, did it crash? No, I didn't crash. I just Control-C'd it, I guess. And it also like totally ignores the comments correctly now, so we do not have to worry about comments anymore. At least I would like to believe that. Okay, cool. So what I'm going to do now is I'm going to again do this. This basically just like disables parsing on other files apart from GW main. Why that? Because, well, when testing, I don't want to, you know, do it on the whole set. It will just take too long. I want to just do it on one file. So yeah. Now, what would be useful would be a list of assembly instructions which are used, and I can either make one automatically or I can somehow get it from them, because we will have to determine if something is an assembly instruction or if it's not an assembly instruction. So I guess I'm going to make a like is assembly is asm instruction, and I'm going to make a set out of it. Cool. So how do we go about it? How many? There aren't that many assembly instructions in all honesty. What we can do is we can cheat a little. I'm going to do it like this. I'm going to remove this for a second, and now I'm going to only basically only look for well, basically only print. I'm going to disable printing the line. I'm going to also disable printing all the tokens. And okay, as token. Cool. Now it shouldn't output anything, just the file names. That's fine. I don't want to output the file names either, so let me disable that. Where is it? Is it? This is parse. Print here. Okay, now it doesn't print anything. So now I want to print the first token if it's... Okay, after the tokenize... Oh, we do not assign it anywhere, so okay. Simple tokens. Now it's assigned to something. So if simple tokens of 0, and this will detect at the same time if I have any lines which have no tokens, and that should not happen, since on the previous processing we are basically eliminating all the empty lines. So if it's wait, the tokenize actually gives us, it's always the token type and the value. Okay, so the token type is equal to stoken, not selector, we want the ident. Then just print it, yeah, basically. Okay, and now let's see what we get. Okay, perfect. Now we get the tokens which are identifiers and are at the beginning. So the assembly instruction will always be at the beginning. Now I'm going to sort it and do -u, which is unique only. So we want to both sort it and print out only the unique stuff. Perfect. And now, I can actually... I wonder if I should do it now, because if I do it in a second, I will be able to eliminate... Because, okay, my plan was that I want to do... Yeah, I will do it in a second. But I want to basically do like a list and then manually like remove everything which is a variable and the label, and then just like, you know, what's left is going to be my list of assembly instructions. Obviously, this was a bad idea, as you can see, because I have a lot of labels and very little assembly instructions, so I'm not going to do that yet. First, I'm going to eliminate... first I'm basically going to eliminate anything which is not... yeah, I'm going to do the second level parsing first, and when I eliminate everything which is not potentially an assembly instruction, then I'm going to go back to it. Okay, so yeah, this doesn't work. And now, I wonder how should I go about it? Should I create something like a token new line, or like a simple token new line, or should I have a list of lines? I probably want to have a list of lines. So in that case, okay, like let's do tokens. And like to process tokens, and we give it a simple tokens. Okay, and this is what we are working on now. So okay, we get simple tokens. Let's print the simple tokens for now. Okay, cool. Okay, so this is going to be a set of, before we get there even, I'm going to create a couple of token types in that case. I am not used to working with one pane, but that's fine. It's a pain to work with one pane. Token is, okay, token types. So one token type would be, let's look at the source code again. It would be this, like, what is it? Is it it's a constant, a macro, a constant assignment? Let's assume it's a constant. That's actually a constant definition. Consdef, yeah, that's better. So this is the first type of a thing we will be looking for. then it will be almost like an AST, but whatever. Okay, is there anything which is like Looking at this, I'm really wondering if I should. Yeah, you know what? I'm going to do it a little differently. Because if I do processing line by line, then processing this will require me to keep more state, and I do not like keeping too much state. So instead of going line by line, I'm going to put all the tokens from the file and have like a new line separator, like an expression and token. So it's token and line end. Let's just call it line end, because why not? It's like an expression and more, but okay, line end, whatever. Okay, I wonder also about these. Oh, thank you for the donation, Nikhil Kumar. There is no text for the donation, I believe. And also, why does YouTube not show me the... There's something wrong with the YouTube chat. Okay, now it works. Yeah, there doesn't seem to be any description. So yeah, thank you for the donation. Okay, cool. So yeah, and we put this after every line. So we go to tokenize. No, we go to parse and we have this. Okay, and simple tokens is actually will be here. Simple tokens is going to be a list. And now we do simple tokens and we is it extend or is it expand? I think it's extend, which basically takes a list and like concatenates it to the list or adds it to the end of the other list. And we are going to do this, and then we are going to do append. Append just adds one element, extends, takes all the elements from the other list and appends them. Okay, and we do this at the end. Perfect. And now we are going to process, not in a loop, not in the loop, outside of a loop, we are going to process simple tokens. So if we print the tokens now, we should get like, yeah, we should get this, which is fine. This is perfect. Okay, this will be a little easier on us. So we have this, then we have like macro, I guess, macro definition. Then we have here, for example, we have a label. And the label is pretty funny, right? Because as you can see, a label, basically after the label, there is like, we should treat this as like basically a new line. So that's good that we are doing it the way we are doing now, because it will actually make it a little bit easier. A label def. Token label def, okay. Then, what other types do we have? So I'm wondering, I'm not really doing tokens right now, I'm doing expressions, right? Maybe I should call it expression instead of token. Yeah, let's call it expression. Expression. No, that's better. Expression as a set of pre-processed tokens which already have some meaning. Then we have this, like a segment switch, basically. So that's like a segment switch. Is it a segment switch? Yeah, it is a segment switch. Segment. I wonder if I should keep it under the same token, but whatever, let's keep it this way. Then obviously, oh, we have this extern thing. I don't know what's that. And by I don't know what's that, I mean I do not know if it actually emits any bytes, or is it just like how to Or is it just like something to tell the linker, hey, like, or the compiler, hey, this is coming from outside? But this is actually really weird. The reason I'm not sure about it is that they are doing this. If it would be just a notification to the compiler that, hey, this freetop word is actually coming from outside, so do not reserve any space for it. But why do I switch to data segment to do it? Maybe it actually creates a pointer to that thing in the data segment. So I'm not really sure about what's going on here. This will be... We'll have to determine it later, basically. Like, and later, I mean when we'll start compiling or emulating or linking, so... Okay. I see there are a couple of questions. I guess we can answer the questions in a second. Let me just finish creating a few first. Is it? I don't know. Let's go to an extern. How do I extern? Extern, okay, so extern definition, let's call it like that. Yeah, when we have like assembly instructions, obviously. Which basically all of these are assembly instruction expressions. I wonder what we are missing. Oh, the subtitle thingy. Yeah, we have to do it, like subtitle. Was there a special... I think there's a special way we actually parsed it. Oh, whatever. Okay, let's just call it subtitle, and there was also a title one at the top, right? So there's radix, there's a title. Okay, then we have include directive. Dear as in a directive. Then we have the radix. I wonder how many dot somethings are there, like stuff which has a dot at the beginning. Okay, could you really use... we'll have to figure it out later. Okay, so this is an include directive, and then we get like a dot. Let's call it a dot directive. And we'll put all the radix and other stuff. Hey, oh, they are changing the radix to 10 here. Wow, that's amazing. To be safe, and then are they changing it back somewhere? They're not changing it back. Now this is really interesting, actually. Because when they have this, should I treat this like... This looks like an octal number. This is going to be a pain. No, these are octal numbers. So why does it say it's changing the radix to 10 when it's actually not? I don't get it. Yeah, dot. Okay, so we have these kinds. You know what? I'm actually going to create a second pane and create a new view into the file, so I can have these constants somewhere here, and I'm going to make this a little bit bigger. Okay. Good. So, okay, so we are here, and now we have tokens, and we need to process the tokens one by one, basically, which isn't true, but that's fine. So while size of... oh, there's actually one more token type at the end. It's called end, which I probably want to handle. That might be pretty useful. I don't think that actually ends the file all the time, but... Am I... how is it actually like if I do this? I get line... Okay, I get ends. Identifier ends, so csec ends. I do not get an end. Well, what's happening with my end? Do I already handle end? There's a line end. Is there an end? Do I detect end? Why do I not see end? Oh no, there is an. There is, sorry, I'm blind. There is obviously this token ident. End. Okay, no, that's fine, that's fine. So expression end. End of file, maybe. End of data. File, end of file. EOF. Let's just call it EOF. EOF. Okay. Perfect. So while I is less than length of tokens, yeah, and this is where the decision tree basically begins. Let's start from the end. If oh, actually, let's no, but that's fine. Let's do it like this. So here's another question, a fun question. If we have something like this, does it have a get method? No, it doesn't. Too bad. I was looking for something like, you know, like dictionaries have a get method, right? Where I can say get ASDFG and then say like, if this is not found, then I want you to return another value, like for example, this one. And yeah, it works like this. And if I would define this actually here, then I would get the value of it. Otherwise, I'd get the default value. And it would be cool for this, but I understand why it's not there, so yeah, whatever. Okay, and if... no, do I have to... I'm wondering... Oh yeah, let's do it like this. It's a little nasty, but whatever. If the simple token is... Oh, too many JavaScript. Too much JavaScript, yeah. Is equal to, if it's equal to line end, we don't really care, but, or rather we will handle that in a second. First, if it's an identifier, and the identifier value is end, like here, then this is the end of data. That's it, break, like end of expressions. We do not do anything more. And here we want to write expressions. Yeah, we want to return expressions. Okay, here this is basically temporary. Maybe I even shouldn't put it here, but let's just go with it. Okay. Cool. I think let's start with printing, like this is a debug print, obviously, right? Printing the next three, so yeah, I to I plus, next 5 tokens maybe. Okay, that's kinda good. If we get here, let's actually just bail out. Good. Okay. So we have a token. Okay. If the token is an identifier, let's do a huge... Actually, we can do it like this. If it's an identifier, if it's and then break. If the token is an identifier, but it's followed by, and I'm not doing any length checking here on purpose. It might crash. I'm fine with it crashing because that means we are not handling something correctly. I'm assuming the code is correct, and yeah. So if the type of the next one is, and there are a couple of things which could happen here, right? In this case, no. Before we even get there, actually, if it starts with a dot, then we know this is basically a dot expression. So we do this. Now I'm wondering about the expression format, but I think I'm going to go with dictionaries because dictionaries are a little bit better to read. So let's go with, yeah, with dictionaries. Okay, and what kind of dot expressions are there? Okay, let's do it like this. Let's just check what kind of... Again, I'm going to do this, because I want to know what kind of dot expressions are there. Dot exp. And that's going to be an S token I of 1. Okay. Okay, radix. Actually, let me uncomment, or rather comment this. And comment this, and do sort dash u. Sort, yes, right, sort. This is exactly what I wanted. Don't do. Yeah. Okay. So it seems there are only 4 dot expressions. That's list, radix, as all. Okay. So actually I would need to find all of them. So okay, list, it seems, is not actually taking any arguments whatsoever. Are there any other? Oh, we can just rgrep. Yeah, list does not take any. How do I force, like? Okay. Okay, list no arguments. Radix takes 1 argument, and it seems we are actually switching all the time. Then all takes no arguments, and there was 1 more, right? Which is xlist. Also does not take any arguments, so that's cool, that's fine. In that case, okay, let's do this again. Cool. So what we are going to do is we are going basically to collect the arguments until the end of the line. So args is going to be this, and we are going to... How? Yeah. We probably need just a function for that, like def. Get still. Like this. Yeah. And this will get like as tokens. Oh, and we probably want also like start index. Okay, so collect while as tokens start index. Okay. As tokens of I of 0 is not equal to what was it called? As token line end. Here we go. If it's not equal, then collected, we append this token, and then we increment the I, and then we increment the I once more to skip this. And then I just return, well, the collected tokens and the new I. So my arguments are actually going to be, I do this and I get inventory. How did this doesn't work at all? Okay. Tokens and start index is I plus 1. And now we get new I and arguments. We can do continue at the end. Here we do break. And here we are going to do this plus the arguments, just to print it and see. Okay, how did that happen? No, like seriously, show me what you're processing. Okay, you're processing this one. Oh, okay, sorry, that's my bad. Because that's not the format I should be using. Yeah, here, the format is obviously like this. Okay, that's better. Okay, so we have a dot expression and KrzaQ. How did you... How... No. Order of things, okay. Dot, I don't know, function, directive, it's a directive, obviously. Here we go. Okay, radix, and then we get a number, literal number as an argument. That's okay. We might like tweak later the format, but for now it's fine. So my expressions are getting a new dictionary, and the dictionary is going to be... Oh, not JavaScript, not JavaScript. Okay. Expression, and then expression dot dir dot directive, yeah. Directive, or like name, maybe name is fine, is the dot directive, and then args are going to be the args which I got. I guess I could also put here like the line number or something. No. Let's keep it like this, maybe I'll change my mind later. Okay, cool. So this has been appended. At the end we can print, like what we have, print. Oh, I would pretty print it actually. How do we pretty print it? With JSON, import JSON. So we do JSON dumps and expressions, and then we do how do JSON dumps pretty print. Well, it's like indent equals 4 and sort equals true. Yeah, indent 4, sort true. I remembered it correctly after. Oh, sort key is not sort. Okay. Why does it? This breaks here. Okay, why did it not print anything? What? Okay, so you go here. Expression, we append to it. I don't get it. Yeah, there is nothing printed with it. Wait, why is there not anything printed? Okay. Because it doesn't print by default. I'm sorry, you didn't see that. You didn't see that. Absolutely, that didn't happen. Yeah, now it's perfect. I'm going to do a minor tweak here. I'm going to call this underscore type, because then when the keys are sorted, it's just going to be on the top. Maybe type with a capital T. Anyway, I shouldn't be hacking like that. Okay, let's keep it like that. Cool. This is a 5-minute break, and I'm going to check if you have any questions. So... the questions should appear here. Again, if you have any questions, you have to ping either today's moderator, that's Fox or Charlie, or if you are on any of our chats, be it Discord, YouTube chat, or IRC, you can type !Q and then the question, and the question goes to my panel, and yeah, I can answer it. So, okay, a question from FTechHar Irani, I'm sorry if I mispronounced it. Have you ever used the WSL for Linux emulation on Windows? I did use it for some project, and but I used VSL1. I didn't play with VSL2 yet. VSL1 was pretty interesting as long, like, in the terms of architecture of it, because it was like literally userland emulation written as a kernel driver for Windows, and it was pretty good. It was surprisingly good. It didn't emulate all of the userland and not a lot of the kernel land either, but yeah, it was pretty good. Not as good as a Linux on a virtual machine. And WSL2 is actually just that, right? It's a Linux on a virtual machine. I might play with it in the future, but I haven't yet. So yeah, I did use WSL for basically for development when I needed to create something on Windows while developing it on Windows, which was also supposed to be running on Linux, but didn't do any weird or fancy Linuxy stuff. Then yeah, I just could test on Windows and Linux at the same time. There were some minor tweaks which I still had to do, but yeah, it worked really well. Christian writes, have you ever used Kira, the timeless debugger developed by GeoHot? How do you compare it to tools like IDA? I think I used Kira once. By the way, I also wrote my engineering degree thesis on that topic, on timeless debuggers. I called it backward debugging back then, by the way. And GDB, by the way, also has this functionality to record an execution, and then you can step back in time, basically, like revert the state of the application. So how does it differ from IDA? It differs in a way that IDA is basically a disassembler. It's an interactive disassembler. It shows the assembly or decompiles the code, but the code is dead. For all intents and purposes, it's dead, meaning it does not have any state, right? There is no memory. There is only how to say it? Only predictions where is what in memory, and constant values, but you cannot say, hey, at this point in code, what's going to be in the registers or in memory. That's not what IDA can do, unless you're running the IDA debugger. But a debugger, you can always go only forward, right? And the idea with timeless debugging, backward debugging, or whatever, is that you record the state basically after execution of each instruction, and or you just actually record the differences in the state. And what you get at the end of the day is the ability to reason based on the changes of the state, and also the ability to just you're analyzing a function and you want to know, hey, what happened 5 instructions before this function was executed, so you can just go back and you can check that. And that, if you play with that and you, for example, want to see how memory layout changes with each malloc allocation, like new allocation or whatever, then it's amazing. It's absolutely amazing. If you are developing an exploit, it's also easy to trace it, because if you want to do the same with a debugger, you need to basically restart the application every time instead of just jumping a few instructions backwards to revert the state. There are some downsides of that, but it might be slow. It might take a lot of space for large applications, but it's a pretty cool tool, and I guess I would expect in the future more tools like that. So but that's my take on it. Yeah, and Kira was pretty amazing, or especially the way GeoHot used it on CTFs. Segment writes, I read basics of assembly x86 and I see coding different NASM and MASM. Okay, why? How come there are any differences there? So basically, I guess there is no assembly syntax standard. Every language, every programming language, like C, JavaScript, C++, PHP even, or Python, have a standard, a document which says this is the exact syntax which you have to use, and these are the features which you need to implement. You might extend it a little bit, but these are the basic features which you need to implement. There is no such thing for assembly. So that means that each time somebody was implementing an assembly compiler, an assembler, they had to, like, they didn't have any restrictions. They could just do it the way they liked. And that's basically what happened. That's why the assembler has like this kind of features and syntax. Macro assembler has this type of features. If you look at other assemblers, you will also find different features, a little bit different syntax. Then there's also the AT&T syntax, which is like totally completely different. But yeah, that's the backstory. There's just no document saying how an assembly syntax should look like, and that's why we have all these differences. And at the end of the day, the differences aren't that big. And if you learn like one syntax, you can switch to a different syntax quite easily. There are some differences. For example, MASM has this super high level language where you can do like if something, then something, and so on. Or like invoke, and this gets compiled into several assembly instructions later on. And NASM, for example, NetWeight assembler does not have it. But yeah, but that's it. You can write the same type of code in each of them at the end of the day using different syntax. So that's basically it. The assembly itself, like the instructions, are almost always identical, with a few minor exceptions on how do you write. Like, for example, do you write byte, do you write byte pointer, do you write like offset, or do you write address? But apart from that, they're like, it's almost identical always. So yeah, like when you're learning assembly, basically you have to be really careful to choose a tutorial for the operating system you're learning for, CPU architecture you're learning for, and the assembly compiler you are learning for. These are like three things. If you, like, I don't know, you are learning for Windows 32-bit x86 and using MASM, and you like have a tutorial which is for Linux, for example, then it just won't work. So you have to have a tutorial or a book or whatever for these three, having all these 3 points checked. If you don't, then that's just not going to work. So yeah, and that assembly compiler is also there. Do note that. So yeah, that's a long answer to that question, basically. Have you ever used Cutter? No, that's a UI for Radari 2, right? But I did it. I have it on my list, but I haven't used it yet. I will do it one day. Cool. Let's go back to coding. Okay. So now it's working. Perfect. So we have this. Okay, this is the first one, expression dot. It's a radix, and it's one argument, it's a literal 8. That's fine. I'm kind of playing with an idea, hey, should we parse the arguments in somehow? But not yet. Let's leave it as is. Okay, so that's one thing. Now, we correctly parsed it. You know what? I'm going to actually take this, and I'm going to put it here, just before the break. So if we do not handle something, then we get it printed. Okay, then we have the CSEG, which is a segment selector. So we do it like this. If that's an identifier, it is, yeah, it's seen like CSEG and DSEG are seen as an identifier, so we can do it like this. If of 1 is equal, no, it's in, and then we do a set of, it's always CSEG or DSEG, right? I think it's always. Let's check it. I think it's always, but error grab segment. Okay, segment. Actually, let's do a grab on segment public and do text. Almost close. And do sort-u. Why does it output the file name? If we do grep-r, does it output the file name too? Yeah, it does, okay. But yeah, I think we can do it another way. We can do grep-v cseg and grep-v. Can you see it? You cannot see me typing at, okay, there. dseg. Yeah, nothing. Okay, so there are only these two. So if it's cseg or it's dseg, and the next token, do we have a special one for a segment, or is it, how is it actually? It's an identifier as well. Okay. Let's do it a little bit like this. Token of 0. It's also an identifier, and the next token is equal to segment. Then in that case, in such a case, we know what kind of an expression is that. Why do you not? Okay, perfect. Then, okay, what do we need? We need to grab all the tokens until the end of the line, so we do again this dance. We do like segment is this, then we get some arguments, but we get actually arguments from 2 because we do not care about this segment thing here. Do we care about the public? Is there anything else apart from the, is there like, is public the only thing there? Okay, yeah, if I'm grepping through, yeah, like segment registers, that's a comment. So grep okay, we grep through segment, but at the beginning of the line there are no comments at the beginning before the segment word. Then we have subtitle, only subtitle, which is basically a comment, so that's fine. There's always a public in that case. There, or is it always a... No, I actually don't know if it's always a public there. There might be, the public might be missing there, so... yeah, let's just grab through segment. But I think I could have left this. No, it's always public. And there's this like... In all honesty, I do not care what's after. Like, it's always code seg, for dseg is always data segment, for cseg is always code segment. Yeah, I don't care. I'm just like, I do need to get all the arguments until the end, but I'm just going to ignore them. I'm absolutely not going to do anything with them. I do not care about this either. Okay, expression, append. Type of the expression is, I believe I had a segment selector, segment switch. It's a segment switch, it's not a segment selector. It's a segment switch. Maybe I should call it a selector, a select. Let's call it a selector. Because why not? Okay, and then segment is, and we get the segment. Cool, continue. That's it. Okay, and that's not it. Okay, cseg, segment selector, and the next one is assume. Special colon cseg. Yeah, I don't think we'll be doing anything. Well, okay, maybe we, because yeah, I don't know. I'm not sure about assume yet. I'm going to create a new expression type, assume. I'm pretty sure we are not going to care about it, but it's an identifier, it's an identifier token. So if it's equal to assume, in such a case, we also need to go... Yeah, we need to get the arguments in this case. And I'm not sure I'm going to do anything with it yet. Do I care about assume? I do not care about assume. What I care about is... So, no, I do not care about this. I care about the arguments from the first one. Yeah, this will be cs, then colon, then cseg. Okay, I'm not doing anything yet with it. could do some additional parsing here. Well, actually, like putting this on left side, putting this on right, whatever. I'm ignoring it for now. So expression assume, then that's an assume directive to be more exact. So what is assume for? It basically tells the compiler that it should assume, for all intents and purposes, that in the CS register there is already a value at this point in the code, and the value is equal to CSEG. So that it basically tells the compiler that if you would need for some reason to know the value of CS, of the CS register, the code segment selector register, then do assume it's already set to the CSEG value. Yeah, that's basically it. That's basically what assume does. Okay, assume name no args yes. Continue. Okay, then we are having this. Then we have assume, and we have ident. Okay, I think assume. I'm playing a little bit with the idea of actually. Let's see all the assumes basically. Let's see all the assumes. I probably should have left it. It's not a comment. Cool. This is some comment. You know what? I'm going to parse it after all. So I'm going to do it like this. Assume, not args, but like reg. And this is going to be the argument 0 of 1. And then the value, it's argument 2, because 1 is the colon and 2 will be, yeah. So this is first value I'm grabbing, and this is the second value I'm grabbing. So yeah, that's perfect. Okay, now let's check it again. Yeah, it's much better. Cool. Now, next one, include. Yeah, special directive include. Okay. This is include is going to be a pain. Yeah, include is going to be a pain because we will have to put the basically before we do anything more inside instead of include, I'm going to include it here, but later on we'll have to replace that expression with the whole list of expressions from that other file. That's going to be a pain. But if it's going to be a pain, let's do it tomorrow or like next week. That's way better. Okay, and then we get the arguments, but we only care about the include directive, and the file name is going to be argument 1. Okay, identify. Wow, that's amazing. Okay. Okay, and now we have it here, which is fine. And now we have title. Yeah, title is an easy one. I don't think we care too much about title. So if identifier is title, then we get all the arguments. We do not care about that. We care about what's the expression name. Here's the expression name and text. Let's do text, and actually let's do the same for title and for subtitle. Can we do it the same? Let's just copy paste it. Okay, subtitle, and we do subtitle here, but the same code. Okay, so now we have, okay, this is the title. Then we have radix.expression, then we have xlist without any arguments, and then we failed at fetoc, assignment operator. Okay, so this is a constant assignment operator probably. So, which it's in, yeah, okay. So this is a kind of a special case because the i+1 of 0 has a different type, and the type is the s-token assignment operator. If this is the case, then the identifier, or like the constant name, it's actually the s-token of I of 1. Then we absolutely ignore the +1 and we go for +2 because these are going to be the arguments of it. So we get the arguments and now we can add the constant. So the constant, what's the constant? We have a constant definition, I knew it. Okay, and now name of the constant, and the name is going to be the const name. And then the arguments. I probably should parse them a little bit more here, but I'm not going to care about that now. I'm going to care about that later. So we put just args here. Let's see what happens now. Okay, which one? Yeah, it fell. There's a lot of stuff being parsed already. Okay, so we have this include title, then the radix, then the x list, and then the. Okay, ftalk is equal to 0. Is that correct? Let's go to the top of it, but we are on the wrong file. We need GW main. Here we go. Okay, and it's comment ftalk equals 0. That's fine. Then the fun one is actually, we go here, for example, 59. Line 59, but label. Sirius Tetra, what are these names? Shiba, is that Toshiba? Oh, here we go, label, and it has a token. Okay, that's good. Okay. So this is fine. Then we have, yeah, this is like alt BLD. This is one which is super fun. This is this one. Yeah, we probably should parse the arguments a little bit harder here, but I'm not going to do that now. I might later have like a third step where I'm going through all the expressions yet again and resolving the include and then resolving all the expression values. I'm not going to do that now. Cool. Okay, let's do this and let's do this and let's see what did we get stuck on. Or actually, you know what? We can go ahead. Okay, and we got stuck on extern. Okay, on the first extern value. So here. I'm going to actually do a grep on extern. Okay, so this is going to be a pain because as you can see it's extern and then like, yeah, it's going to be a pain. Because it's actually a list, right? So we have to handle it like a list. This might be actually fine. XTRN, okay. We are getting the arguments from 1. Yeah. Yeah, and now it starts to be fun. Okay. While j is args j is equals 3, we have name is args of j plus 0 and type. That's it. What's the difference between near and word? Because near sounds to me like it's a, oh, it's a near pointer probably. Near pointer and a word. Okay, that makes sense. I did expect that PTR there. Type, I'm shadowing the type function. I don't think I'm using type anywhere, so that's fine. Okay, and type it's args. I probably should check if there's a colon in between, but again, I'm not writing a perfect compiler, I'm writing a compiler which compiles this code. Well, compiler, I don't know, maybe I'm writing an emulator, I still don't know, so... Okay, we do this, and now we do... By the way, sometimes I do something like this, like -3 here, and then I put this here so I don't forget it later. But I'm guessing you shouldn't do that. That's a nice hug though. Okay, and now we are going to add the expressions. So that's external definition. We have the name is the name, and the type is the type. Okay, and yeah, this should be fine. This should actually be nice. Let's see, there's this. Actually, I want to go to the line which is long. Okay, this one. How do I? Okay, this is fine. I don't think I'm reaching it yet. Yeah, I don't think I'm reaching it yet. Let's do, in that case, head and see what I'm stuck on. I'm stuck on the seg and oh, okay, on ending of a segment. Okay, I'm going to, I guess, code it here. Okay, I'm just going to copy paste it. And s token I plus 1 of 0 is an identifier, and I could have like just copied everything here. It's not a segment, but it's ends with an s at the end. That means end segment. In such a case, we grab this and we copy this. And okay, the segment is the one which is at the front, which is correct. Then we get I plus 1. It just gets the arguments until the end. There are. Yeah, this is just like, this is fine, it can stay here. I absolutely do not care about what it grabs, as long as it iterates until the end of the line. And then here is not segment selector, it's the segment end, and we end the segment, that's fine. We can continue. Okay, that's not nice. What happened? J plus 2. I know where we have J plus 2. We have J plus 2 here. Could you print args for me? Okay, no. Could you print args, like 3 args for me? Okay, like this. J plus J, here we go. Okay. Oh, comma, I totally forgot about the comma operator. Oops. Plus 4. Yeah, my bad. Okay, that's better. My bad, absolutely. Cool. Okay, let's see what it crashes now on. It crashes on public. Public auto. What's public? What's public? Public. What is this? Oh. List of labels which are exported, which are defined in this file, but they are exported. In that case, we create another expression which we called, let's call it public, because why not? I mean, it's called public here, so I'm not going to change the name to export. I could though, but I'm not going to. And it's one of these. Let's just copy subtitle, I think. Oh no, I'm going to copy extern because it's actually also a list with commas. I'm not doing any error checking here. I probably should be doing error checking. I am not doing any error checking, and this is going to bite me on the ass when we will start debugging it later on. Mark my words. Okay, we just do +2 here. There is the name. And for each of them, we actually exported. Yeah, as you can see, I'm like splitting such a thing. For such a thing, I'm treating it as like 5 expressions instead of just 1 expression. This is going to be easier on me later on. So there's only the name, there is no type. Here we go. And I think it's going to be fine. Cool. What's next? Identifier and there's a special colon. Okay. If we have an identifier which is followed by a colon, that means it's a label. So we finally got somewhere here where we can get the labels. So comma, not comma, where's the colon operator? So what's the special colon? Special colon. Oh, it's here. Okay. Yes, absolutely. That's the name of it. This is basically one of these where I'm not using this one. Though, yeah, I'm not using this one. I'm going to do something else in a second. Okay. I will have to make an array or like a dictionary even of labels later with pointers to this expression array, but I'm not going to do it now. I'm going to do it later in some other pass. It's going to be like a totally multi-pass. You usually want to have like a limited amount of passes because then it's faster, but we don't care. It can be slow. Even if we write an emulator and it will be super slow, it will be still faster. Probably it will be still faster when our computers were in 85, so that's fine. Will it be faster? What was the speed of like a PC in 85? That was like 1 megahertz, I would say, maybe a little faster. And I have what, like 4 gigahertz here. Does that offset? Would this offset actually all the? Maybe it will be too slow. We'll see. Okay. Fiang or F-Jung writes, you have now copied the double assignment of type back for 301. Type. Oh, that's a fair point. Thank you very much. That's a good, yeah, that was great. Like, really well spotted. I have, yeah, a name collision on the fields. It's funny that Python doesn't actually check for this. But, well, Python almost doesn't check almost for anything, so it's fine. How do I call it in that case, if not type? It's usually called type. Okay, let's do it. Var type. Thank you. Well spotted. Really well spotted. JetBrains would spot it. Okay, that's good to know. Really, that's quite amazing actually. Okay, yeah, we are doing this. So label name is token 1. Then we okay. Now we have the colon after that, so we need to increase I by 2. Okay, and now expression append, and we append. The type is going to be label expression type label definition. And the name is going to be label name. Okay, and we do continue. Now, we might end up here in... Okay, so in this case, as you can see, we do not have the end of a line immediately. We have the assembly instruction starting on. But this is like, we already parsed a lot of non-assembly stuff, and now we finally reach some assembly instructions. It took a while, right? It took like quite a lot of code, but we are finally at an assembly instruction. So, but before we get there, what I want to do is I want to basically do if the token type is end of a line, then I absolutely do not care about it. Please just continue. Thank you. Cool. Okay. And now we are at an identifier, which is potentially an assembly instruction. Cool. Okay, I'm going to comment this out. Here, we are still, it's an identifier. So what I'm going to do is I'm going to do like a catch all. Because first I want to catch all cases. I might still have to do something from here. But yeah, before we get there, catch all, then we get all the arguments, like I don't know, tokens, whatever, tokens, and I get all the tokens until end of the line from here and print them. And do continue. Thank you. Good. And there is a really huge, yeah, it's really possible right now that all these identifiers are assembly instructions. So before we do that, yeah, it's like all of them are. Okay, let's go to the top of the file because I would, okay, so let's not go to the top of the file, I'm just going to do this. Okay, and we actually get to the end of a file, no problems, no worries, which isn't true probably. Show me what identifier do we have? We have red doext. Doext, what are you? No, seriously, what's doext? Is this some kind of a macro? I don't know. Are we handling ends already somewhere? Ends, yeah, we are. Okay, good. So, no, we can actually, yeah, we are probably getting here, which is perfect. This is perfect. So what I need to do now is I need to put, do this. Yeah. No, wait, that was good. That's a 0. 1. Yeah. Okay. And now I'm going to close my eyes and uncomment this. I'm sorry, I'm closing my eyes. I cannot look. Okay, I can look. Okay. It's pretty decent. It crashed at one file, but I think we'll get almost every assembly instruction now. So I'm going to do sort-u. Okay. We are still... What is this? Why are we still getting some stuff? Like this, like temp3. What's temp3? Okay. What is this? Public temp3, okay. Marble82, thank you for the donation. When will you write unit tests? Unit tests, nervous laughter. Yeah, well, I write unit tests when I'm writing real kind of production code. This isn't real kind of production code, so yeah, there are a lot of tests which I'm not writing right now, like end-to-end tests, unit tests, integration tests, and so on and so forth. So yeah, nervous laughter, insert more nervous laughter here. Cool. What is this? Temp3 labor word. I know what is this, but why do they feel the need to call it, to put the label here? Couldn't they just... Oh, because they want a type. That's why. Oh, nice. Okay, now I get it. Because normal labels do not have a type. So we will have to handle this too before we play more with it. Okay, how are we going to do that? We are going to do that by going... Yeah, I guess this one is good. No. Where's my label? Is this a label? This is perfect. Okay. Can you hear the thunder in the background? I wonder if you can like triangulate my position based on the thunder. Probably no, because there is a delay in the live stream and you do not know the exact value of the delay. Okay. Yeah, there would be no delay, but it would be good. On the other hand, if you would see a flash would tell you what's the delay. Oh well, you'll figure it out, you're smart. If it's +1 is an identifier as well, and the identifier is equal to label, then let's call it a variable label actually. So here we have a label definition, but there's going to be a variable label definition as well. We can know the delay by the way you send the links. Press enter and we saw yes, that's a good point, but I think it still won't be precise enough. But it's a good point, I know, that's a good idea. Okay, so yeah, we'll do this one. Okay, this is the variable label, then we have the label, and then we have the type. The type are... can we do a grep over label? Label equals really. Okay, I think there's a space before and after. But that's not a space, that's a... okay, let's do... Is it like \s for space? Yeah, okay. I hope we are processing subtitle before. Yeah, we are. Otherwise, this one would be really nasty. Right, because it's like subtitle followed by a label, so we would totally fall into this if. And key would be selected as the type. That's really bad. Okay. And not a lot of that, actually. That's fine. So, let's go back to my label. Okay, type, that's I, and type is 2. Yeah, that's 0, 1, 2. Are we grabbing stuff until the end of the line? We should be grabbing stuff until the line. So let's actually do it like this. Grab it from here. And then here we grab arcs of 0, arcs of 2. We do not touch this. And here we do this label name, that's variable label name this time, and var type. Yeah, this time I'm careful, as you can see. Type name, no, just type. Okay, that should be fine. Okay, now it's better. This absolutely does not look like... this is probably a macro. Call equals... oh, that's funny. We do not have equal yet. Equal is just a... that's just a constant. I wonder why do they sometimes use equal and sometimes use like the assignment? Because equal is usually like equals to. So they have what? They do a subroutine scroll to, no. Okay, they do define somewhere scroll, and let's just take a look at that file, scn to. Here we go. Scroll. Okay, so yeah, we have this scroll. I absolutely do not get what we are trying to achieve here, but that doesn't matter, I think. Look for equal. yeah, eq. I even can't write eq. I think we're using tabs on this. Oh yeah, here we go. Is this part of a macro? Okay, what is going on here? Why do they have funny characters in the middle of... What is IFN? What am I looking at? I have no idea what's IFN, but I feel we are going to learn really fast. That's weird. Is it some kind of a macro syntax? Oh well. Okay. Let's dispose of eq as well. I'm going to call it an eq expression in that case. Expression like eq definition, maybe eq definition sounds fine. Okay, so that's eq definition. If we have an identifier and then an eq, then we absolutely need the arguments in that case. But we are grabbing the arguments from here. So var label, or is it a const name? I think it's a const name. It's actually going to be from stokens I of 1. Okay. This is the const. When we get arguments, because we have eq, so that's +2, that's fine. And we don't get this. Actually, you know what? We should grab over equals because I need to see what kind of what kind of variants do they have on it. Yeah, they have some weird stuff here. Well, 128D, is this a decimal? What's a decimal? This, oh, I think we already established it some time ago, but yeah, if something has D at the end, it's actually a decimal instead of an octal. Octal was pretty popular back in the days, but yeah, it went away. Okay, that's fine. We can actually pretty much do, no, not type, but args. Let's go with args for now. Equal args and name is const. Okay, let's try now again. Okay, T is absolutely or absolutely not looking like an assembly instruction. Where did we get a T or like a R1? But most of these are assembly instructions. Enough of... Okay. What are you? It's a macro. Okay. A macro. We cannot do anything about macros yet. Especially if they are, like, it's not the definition of macro. We could do something about the definition of a macro. We cannot do anything about the usage of the macro yet. So that means I'm actually going to... I'm also leaving the macro probably at to the next episode because it's going to be a pain to parse. So for now, I'm going to just go with... yeah, I'm just going to go with this, and I'm going to... Perfect. It actually fails on one file, but I don't think we should care too much about it. I'm going to write it to like as some instructions. Okay, and these are the assembly instructions. I'm going to remove everything which doesn't look like an assembly instruction. ADR, ADRP. Is there something like ADR? I do not... Okay, I think I'm going to be doing a lot of grepping. I do not think there is an instruction called ADR. It's the macro. They are using a lot of that. But I don't think that's an assembly instruction. Okay, GW data. Let's see the context where it's used. GW data. ADR. I'm going to take a look at the questions in a second. Yeah, this is a macro. ADRP is a macro. What's an ADR? You know what, I'm going to do this and grab macro. Macro and ADR, yeah, it's a macro. And cal OS, I'm pretty sure this is a macro as well. Yeah, it's a macro. CB, I think that's a macro as well. Okay, it's not a macro. What are you? CBW. Okay, I have no idea what's that. x86 CBW, what are you? Convert. Oh, that's okay. I never used this one, I used these ones though. Oh, that's fine. Yeah, it's basically like a sign extension of like you have a byte and it does a sign extension to 16 bits. That's fine. This should be an assembly instruction. Yeah, we can do this test. X86. Yeah, clear carry flag, clear direction flag, clear interrupt flag. CMC does not sound like an x86 instruction. Oh, complement carry flag. I do not believe I ever used this instruction. CMP, absolutely. This is signed word. Is this like some kind of a macro, or is there actually like a compare with signed word? Oh, there is. Okay, that's fine. CMP XIO, no, that doesn't sound like an instruction. Yeah, no, that's a macro, absolutely. Macro, yeah. DB is a directive, so DB goes away. DC, what's a DC? DC is a macro, so is DCE, DCL, and DCUL. Okay, DEC is not Dermac. Dermac doesn't sound like an assembly instruction. Dev doesn't sound like an assembly instruction either. Yeah, that's a macro. And dev2. DoExt, no. DOS.io, no. No, DOS.io, absolutely not. That's a macro. Where did we get this one from? Oh, wow. They literally have one thing in the whole code base which is lowercase, and that's dummy with a typo. Okay. DW, no, that's a and if. Oh, there's an and if which we need to handle? I didn't know that. That's not good. And yeah, we'll have to handle and if, it seems, later. And macro, no. Half DE, I have no idea what's half DE. It's a macro. Maybe I should do this here. Yeah. That's a macro. Half HL, that's absolutely a macro as well. Yeah, that's a macro. IDIF is fine. IFE, that should be either a macro or some kind of a directive, which we need to find. IFE, what are you? Yeah, that's an if equals, so that's fine. In is an instruction. In C maybe. Oh, but that's not in C, that's inc. Wow, that was tunnel vision at its finest. This isn't an instruction. This is a weird thing they are doing. IRED is an instruction. These are jumps, absolutely fine. Okay, Lia less is load ES register. Load AF, that's fine. This is load flag register to AF, or the other way around. Move names absolutely not, and if is a macro. Negde. Negde sounds like a macro. Yeah, negde is a macro and HL will be a macro as well. Not or org no, and page also no. org will be a directive which we'll have to handle at some point. Yeah, that will be a directive. Directive, page 2. Pop, pop F, pop R? What's pop R? I don't know pop R. It's macro, hello. Okay. Push flag, QF, no, R1, no. These ones, yeah, these should be instructions. X86 RCL. Yeah, that rotates. Okay, that's fine. Rep. These aren't instructions, but these are. Maybe I should treat them as instructions. I'm going to treat them as instructions. Technically, these. What are we doing in like code from 85? I thought they added the rep and this stuff later on. This is like, yeah. What seriously? Like, what was it added? I thought that was added like in the 90s. It's not a macro. It's actually like, this is a proper usage of repni. Repni isn't an instruction, it's a prefix to an instruction. This is the instruction and this is the prefix, but I'm going to treat it as an instruction. But yeah, like string, what is it called? Like streaming string instruction, something like that. No, okay, this isn't working too well. But seriously, I thought that was added later on. I am really surprised to see repna in this code. Rept sounds like a macro. Oh, it's not a macro. What is it? No, this is, okay, so this is not a macro, but it will be something else. This doesn't look like SAH looks fine. Sal, SBB is subtract with borrow. These are shifts. STC is set carry flag, set direction flag, set interrupt flag. Then these are fine. T no, these are fine. Xlat. What was Xlat translating? It was translating something, but I don't remember what was it translating. X86, Xlat. Oh yeah, that's a fine one. That's a fun one. Okay, we can leave it. But yeah, it's basically set AL to EBX and plus something. It basically like grabs. You have in AL an index in a array, and that grabs the element from that array. It's not commonly used. I think I've used it once or twice in some weird scenarios. Okay, a second look. Is everything here really an assembly instruction? I think it is. How many assembly instructions do we have? 89. Because this is important. Okay, this is like adjust after multiplication, something like that. ASCII adjust after multiplication, yeah. This is, if we are going to create an emulator, we'll have to implement 89 instructions. Most of them are trivial to implement apart from the flag, so yeah, that's a lot. Maybe we'll go the compiler route after all. Okay, let's do, where are we going to split it? Here. Split it here. Okay. Oh wow. What the hell? Okay, that didn't work too well. No, it's fine, it's fine. It's fine actually. This one is not fine. Okay. Okay, I think I'm going to switch to questions in a second, and we are going to be finalizing the stream. So let's just copy these instructions here. Okay, this is what I wanted to do at the beginning of a stream. So we go now to here to our expressions, and if token I of 1 is in in that case we are grabbing everything, or are we grabbing everything? Yeah, let's just grab everything. Everything or everything after. Let's just grab everything. And put it like expressions append here. Type is expression assembly instruction. Here we go. Then args is. Thinking maybe I should actually grab the. Okay, I'm grabbing the first one. Args and instruction. Okay. Cool. So I'm going to comment out this, and I'm going to do this, and I'm going to run it. And let's see what's the state for the end of the day. Okay, it's still outputting everything. I don't want it to output everything. Let's remove the catch-all. Okay, and actually let's do a head. Yeah, it still is crashing at something. At the IFN. Identifier IFN. So let's go back to the main. IFN, what is IFN? Oh, dermac IFN. What's dermac? No, dermac was a macro, right? We cannot do anything about macros yet. I think it's going to be the next time we'll be playing with. Yeah, that's a macro. Okay, so next time we'll have to play with macros, but for now it's pretty fine. We got like something we can work with, or we are getting somewhere we can work with. We still have several directives to handle. We have the macros to handle, and that's going to be the next episode, I think. And after that, I will have to decide if I'm going the compiler route or if I'm going the emulator route. We would have 80 instructions to emulate, but at the end of the day, I don't really have to emulate them. I can use something to emulate them. So yeah, I'll think about it. Okay, let's go to the questions, and then we'll continue next week. Here we go. Questions will, well, I hope they will be showing them here. Okay, here we go. So, Ido writes, regarding previous question, WSL2 potentially could be a replacement for your VM, or will you still want to leave VirtualBox for more flexibility? So, it's like this. I'm going to play with it a bit, but I'm not going